Notes 12, page 2. We just saw factoring by substitution, which is the last factoring technique that we're going to cover. So we've seen all the factoring techniques. You need to be able to put them in perspective and, when do I use which technique? So this page here is kind of your factoring Bible. So you want to basically get comfortable with this sequence and these patterns. So when you're factoring, the first step is always look for and factor out any GCF. If you forget to factor out a GCF, you might not recognize what happens next. Okay? Now, after you factor something out, make sure every factor is a prime. There may be another step. You might be able to factor some more. So after you factor out the GCF, count the terms. The number of terms your problem has gives you a big hint as to the factoring technique you might be needing to use. If it's 2 terms, there are 3 patterns. Okay? So there's the difference of 2 squares, there's the difference of 2 cubes, and the sum of 2 cubes. Okay, remember, the sum of 2 squares is prime. You cannot factor that over the reals. If there are 3 terms, first check to see if you have a trinomial square pattern. That is, does it factor as the square of a binomial? Because if it fits that pattern, you don't have to think about it. Boom, you've got it factored. If it doesn't fit that pattern, maybe it's FOIL in reverse. So that's where you you write out the 2 blank parentheses and basically guess and check. If it's 3 terms, it might be in quadratic form. That's our latest technique. Well, one of the clues for quadratic form is it looks pretty ugly. Okay, it looks weird. Okay, but the big clue is it should have 3 terms. The last term or the first term should be a constant. You should find a variable part that has an exponent that's twice as big as an exponent on that same variable in another term. And the substitution you make is u is always the variable part with the smaller of the 2 exponents. Okay. Then finally, if there are 4 terms, grouping. Okay, so remember the goal of grouping is you're trying to create a binomial GCF. And remember, you are not done factoring until your final answer is all 1 term and every factor is prime. Okay, so let's try these 2 problems here. All right, factor completely. First step, look for a GCF. And if you need to, x to the first is the same as x to 3/3, so that might help you out. But we do see that x is common to all the terms, so the GCF is x to the 3/3 if that helps, or just x to the first. When you're factoring out a GCF, you write your GCF out in front of blank parentheses. X times what will give me 4x to the 5/3. See how writing it as 3/3 kind of helps you out? When you're multiplying the same base, you add the exponents. So 3/3 plus what would give me 5/3? Oh, that would have to be x to the 2/3. And of course we need the 4, so that'd be 4x to the 2/3. All right. Minus, of course, there's the 12. And then x to the 3/3 times x to the what would give me x to the 4/3. When you multiply the same base, you add the exponents, so this would have to be a 1/3. And then clearly just a -7. All right. So don't stop here. Check to see if all your factors are prime. One thing I'm going to do is, now that I've factored out the GCF, the 3/3 has kind of served its purpose. Let me just write that as x to the first. Now I'm looking at this, it's like, oh, that's kind of ugly, it's weird, but it does have 3 terms. And check this out. This exponent on the x is twice as big as this exponent on that x. So this would be something that's called in quadratic form, and I could use substitution. My substitute variable is u. You can make it pretty much anything you want, don't make it x again, but the common substitute variable is u. And we're always going to make u be the variable part that has the smaller exponent. It'd be x to the 1/3. Now, notice that if you square u, that would mean you squared x to the 1/3, and then power to a power, that's x to the 2/3. So when you do this the right way, your substitute variable is u, and this one over here ought to be u squared. So this will be 4 u squared minus 12 u minus 7. That looks like a typical reversing FOIL problem. No pattern because 7's not a perfect square. I'm going to open the 2 blank parentheses. I'm going to carry down my GCF. It really, really helps to frame your thinking, to write down what you know for certain. And you know it has to be a 7 and a 1 in the back. You could write 1 and 7, doesn't matter, but the only way to multiply 2 numbers to get 7 is 7 times 1. Now I know it's a minus and a plus, and my options here are 4 and 1, and I think if I put the 4 here, that's like way too big. If I put the 4 here, I just not feeling it. I'm going to try the 2, 2u, 2u, so 2 and 2. Now check the middle term. Outer is 2u, inner is 14u. Okay, now we know because this is negative, it'll be 1 plus, 1 minus, so we know these two values will subtract, and 14 minus 2 is indeed 12, but I need the 12 to be negative, so I need the 14 to be negative and the 2 to be positive. So to make that happen, I need to put the plus here and the minus there. And now, you're not done. U was just a substitute variable to help us see what was going on. It just helped us visualize how to factor this. We need to factor this using an x, so I put what u is standing in for back in, substitute the x to the 1/3 back in, and then I'm done. This is all one term. Each factor is prime. And if you multiply this back out, you will get the original expression. Okay, so let's try the next one. This one for some people is really hard. And that's because I'm kind of obscuring what's going on by the way I wrote it. But it does come up, this kind of problem can come up fairly frequently. So, first step, is there a GCF? Nope, no GCF. And then, boy, it's ugly and it's looking like a pattern. I think I'm gonna deal with the ugliness first. If this is really in quadratic form, then the exponent here has to be half as big as the exponent there. This is a 1, and I don't see an exponent at all, and that's what's really throwing me off. But I know the square root of m is the same as m to the 1/2 power. And now I see it. I have a constant, my variable, this exponent here, and then this exponent here. So 1 is twice as big as that exponent here. So this is in quadratic form. I can use substitution. I can let u be m to the 1/2. If you saw this right away, you might have just said u was the square root of m. Okay? So what I know is this is u. And then I have to see, well, how would I write m using u? Well, this pattern keeps happening. If you take u and square it, that would mean you squared the square root of m, and that's m. So m is u squared. So this would be 4u squared and plus 49. Now I can see it. This is a typical FOIL problem, and boy, those first and last terms are totally jumping out at me. 49 is a perfect square. The square root of 49 is 7. The square root of 4u squared is 2u. If I take 2u times 7, I get 14u. Double that, 28u. Yep, it fits the pattern. Because this is a minus, it'll be a minus in the middle of the binomial. And it's the same factor twice. 2u minus 7 quantity squared. And then finally, u is standing in for m to the 1/2. But let's keep our rule that if a problem starts in radical form, let's give the final answer in radical form. So 2 times the square root of m minus 7 quantity squared. That's how that factors. Okay, that's kind of the end of our factoring. And now we're going to be using factoring to simplify rational expressions.